Chapter 3b, Circuit Theorem, DC Analysis Circuit. This chapter is aimed to explain the Thevenin theorems and Norton theorem principle in solving problems related to electric circuit. The expected outcome will be students should be able to understand and apply the steps for solving the circuit problem using Thevenin theorems, understands and apply the step for solving the circuit problem using Norton theorem, finds the maximum power transfer. This chapter will cover 7.1 Thevenin and Norton theorems, independent and dependent source, 7.2 maximum power transfer. Let's start with the Thevenin theorems. What is the purpose of the Thevenin theorem? Thevenin theorem is used to replace the whole circuit between the two terminals with an equivalent simple circuit, R Thevenin and V Thevenin. A voltage source VTH in series with one resistant RTH. TH stands for the Thevenin. Thevenin's theorem states that any two-terminal linear circuit can be replaced by an equivalent circuit consisting of voltage source in series with a single equivalent resistant. This is the equivalent circuit for the Thevenin. As you can see that you have to transform one complicated circuit that consists of a numbers of resistors, a numbers of source, either voltage source or current source, and then you have to transform that circuits to be the R or V Thevenin circuit, which is the equivalent circuits of the Thevenin. So this is the equivalent circuit of Thevenin's equivalent circuit. So it means that you have to convert R1, R2, R3 by using some simplified circuit and some process, and then converts that so that it only have only one resistor, which is we call that as a R Thevenin. And then if the circuit or the original circuit consists of V, V2, current source, you have to convert that so that the Thevenin equivalent circuit only consists one V Thevenin. And then we assume that this one as a black box. Okay. And then you will be connect with the load at the ends of the terminal. So usually we choose AB and then connect with the R load as shown in this circuit. This is the process flow in order to transform the circuit to be the Thevenin equivalent circuit. First is from the original circuit, please remove the RL. Then after you remove the RL, and then finds the R Thevenin, which is the Thevenin equivalent resistance, by terminate the source. For example, if the circuit consists of V source, and then you have to terminate the source by short circuit the source. And for the current source, you have to terminate the current source by open circuit the terminals of current source. And then at the terminals of the RL, you have to find the V Thevenin, which is the Thevenin's equivalent voltage. And then after you find the R Thevenin and V Thevenin, substitute that into the Thevenin equivalent circuit, which is here, V Thevenins and R Thevenin. And then insert the RL that you already moved in the first step into that circuit. And then solve the circuit. For example, the circuit need you to find the currents that flow to the RL. And then by using the V Thevenins and R Thevenins, which is in the Thevenin equivalent circuit, you are able to find the currents or voltage across the RL or flowing through the RL. As for example, this is the example of a circuit. So then for the first step, you have to remove the RL. So you need to remove the RL. After you remove the RL, mark it with the AB. And then you need to find the R Thevenin by short circuit the voltage source and open circuit the current source. So here you need to short circuit and then open circuit. Then you have to find the R Thevenin from the terminal AB. So it seems that the R Thevenin is equal to R1 series with R2 and series with the R3. Okay, for the next step, which is you have to find the Thevenins. Okay, use the previous circuit. Go and then mark the V Thevenins. So V Thevenin as a terminal AB. And then you can use any method in order to find the V Thevenins across the terminal AB by using nodal, mesh, voltage divider, KVL, KCL, superposition, source transformation. So any kinds of circuit methods that you like. Okay, after you find the R Thevenin and V Thevenins, and then transforms the circuit to be the Thevenin equivalent circuit by puts or insert the values of V Thevenin and then the R Thevenins into the circuit. For example, here. And then insert back the RL into the circuit. As for example, in previous circuit, if the question asks you to find the IA, as stated here, so you can just find the IA by using the Thevenin equivalent circuit problem.